Hello guys, this video will show you how to solve permutations using breadth search. In the previous video we saw this one in depth search functions, right? But for this one we're going to use breadth search instead. Given a set of distinct numbers by all of its permutations. Permutations is defined as a rearranging of elements of set. Right? For example, 1, 2, 3. If I have 6 permutations, right? So let's look at the depth of search that we saw already. You can see at each level of the tree, each node here is recursive where we trying to find the next number of our current permutations, right? First level, we're finding the first slot of our permutation. Next, find the second slot. Next, we find the next slot, right? And so on. So for breadth first search, we wanna go level by level, right? So for breadth first search, we're gonna start with a with an empty array, right? At each level, we're gonna consider a number in our input, right? So there are 3 numbers. So it's correspond to 3 levels. First level, second level, we're gonna consider 2, last let's consider 3, right? So the root here we have an empty permutations, right? So at the first level we're considering 1 and want to add 1 to every permutations in previous step, right? So in the previous step we have 1 permutations, which is an empty array, right? So here we have only 1 choice, right? Which is add 1 to the permutations of previous step, right? So let's go to the next level. Now 2. Now we're considering 2 as next level. So for 2 here, we wanna try to add to previous permutations. So there's 1 permutations, right? So we have 2 choices here. the first one is to append 2 before 1, right? Second one is append 2 after 1. So you have two choices. One, 2, and 2, 1. Right. 2, 1, and 1, 2. Okay. Okay. So now we're considering 3. So for each permutations of the previous level, we have so for this one, for example, there's 2 elements, so there are 3 choices, right? 3 can be here, or can be in the middle, or in the last, right? So for each permutations of previous level, if permutations has n elements, then we have n plus 1 choices in the next level. So down here, so for each item in the previous level, we have 3 choices here. First one, 3, 2, 1. Next one, 3, 1, 3, 1. So 2, 3, 1. Next one, 2, 1, 3. Okay. Next choices. For the next permutations, 1, 2 with 3 choices as well. So 3, 1, 2. 1, 3, 2. Okay. 1, 2, 3. Okay. So after iterating, after processing this last element, this last number in our input, which is 3, we have a complete list of permutations or permutations, right? So that's it for this problem. In order to process level by level, as you can see, we are using the input from the previous steps, right? So, for example, the second level we're using 1, right? We must process every permutations in previous step, right? So for third level, we need to process 2 items, 2 permutations in the previous step, right? And for each item, we'll try to allocate the current number, which is 3, to a how to say, a slot in each permutations. Right. So in order to do so, wanna use a heap. Gonna use a queue, right? So process level by level. So I'm going to use a queue to store all the queue will store permutations of current level, right? So at each iteration, we're gonna process one level, right? So let's say I want to use a queue. Let's say okay, we have new queue. The queue will, I'm gonna initialize the queue with an empty array, which is this one. Right? So when a process, gonna start the process level by level. At each level is at each level we're consider one number in the input, right? So for let of numbers, okay, process current level. So at the beginning of each iterations, we need to remember the queue size, right? Because as we process the current level, we're gonna add more elements to the queue. So before process one level, we want to remember the size level. So we only process that amount of elements, right? Const level size is equal to queue size at the moment. Okay. So when process exactly that amount, level size greater than 0. Okay. As long as, right? So for each iteration, gonna reduce level size by 1. So wanna dequeue the next permutations, permutation out is q dot shift. Okay, here's what dequeue permutations out. So for each permutation now, wanna try to generate new permutations using the current number. Let's call it current number. Okay. In order to do so, how about using a utility functions here? I'm gonna abstract out this logic into another functions. Generate new permutations. permutations. Okay, gonna pass in the Q or Q, right? Gonna add new permutations to the Q, right? And okay, and gonna pass in the permutations out and the current number as well. Current number and current permutations. Permutation now. Okay. So after this will be responsible for adding new permutations using the current number to the queue. Right? So we dequeue this one now. Use 3 combined with this one to produce 3 new permutations. Right? So for each item of the previous level, so we process all permutations from previous level here. So after exit here, we're done, right? What else we need to do here? Maybe we need to return probably the queue. Not sure what it is here. Queue equal to new queue. One, two, for example, queue now. Queue dot content. No. Queue array. Queue. Oops. Array from queue. Okay. This is the one. This one first and then 2, 1, 2. So the news element come in this way. And the first element come in, you go out this way. So that's it. We return array from a queue. So after processing all the elements, we will have our queue contains all permutations. Right. Last thing to do here is to implement generate new permutations, passing in the queue, current number, previous permutations. Here is a array, a number and queue. Okay. So, for example, previous permutations will be x and y. Current number will be z, right? So In this case, there are three choices. For the input of two numbers, right? Z, X, Y, X, Y. Z, Y, that's wrong. X, Y, Z. Okay. So three choices. So it means for input of n, would have n plus 1 choices, right? So we can use previous permutation length, right? So when I use a loop, let I equal to 0, I less than 0, 1, 2. Less than or equal to previous permutation dot length. So for example, this is 2, right? Length is 2. We have 3 slots. There's 3 slots to put in, which is 0 is the first slot, right? 1 is the second slot, and 2 is the last slot, right? So I will run from 0 to permutation length. So I plus plus. Okay, so for each slot, gonna create a new array representing the permutations, then add it to the queue, right? So for each so for example, I equal to 0, let's say I equal to 1, right? It means we're putting the column to the index 1, right? So we can create a new array, new permutation is a new array, right? X column and Y. X here will be is actually what say we're using concat. No, that's okay. Wanna slide, right? Wanna slide, which is previous permutations dot slice. Wanna slide if we insert index 1, so we're gonna slide from the index 0 to the end index exclusively, which is I. Okay, this will return a new array. Let's spread it out. Then to current number, right? Current number will be at I. Okay, then gonna slide again. Slides. We'll run from I, right? So for the new, this will slide from I to the end, right? This will be from 0 to I minus 1. I here is the last index, but not included. Okay, here we have new permutations. I'm gonna push this queue, add new permutation. Right. So let's see. Just 10, 3. Let instead. Okay, works. BFS. Let's say return. Okay. So that's it for this, for the permutations using breadth first search. So thanks for watching. See you in the next one.